In this video, I'm going to talk about the quadratic family. We're going to explore the characteristics of this function, both with the equation and with the graph, and look at translations with the quadratic family. To start off, the parent function of the quadratic family is the equation y equals x squared. The main key when you're looking at the equation to tell I think it's quadratic is this exponent. We have an x squared in the equation, and there are no higher exponents. So let's look at the graph of this function y equals x squared. The graph y equals x squared here is graphed on the right, and this is called a parabola. Let's write on here, parabola. It's kind of a U-shaped. One of the important things about this is we see it is symmetrical. Which is, if we look at this, it looks like a mirror image. We can put a line right down the middle, kind of cut it in half, and as we do this, one side is a mirror image of the other side. And in fact, if you take any point on one side of this parabola, and we say this one point is two sides from that center, we go two sides to the other side, we get another point on the same parabola. This is one of the nice features about this function. This line that cuts this in half that we're doing that reflection about, this is what we call the axis of symmetry. Another key aspect of this graph is if we look right here where this axis of symmetry intercepts the curve, that's kind of where it turns around. The graph is coming down, this is the lowest point, it's where it turns up and goes back up again. So this point right there, where it crosses the axis of symmetry, this is what we call the vertex. And in the parent, the vertex is the point 0, 0. On the parent, the axis of symmetry is the equation y, no, it's not y, I keep on doing that mistake. No, undo. X equals 0. Because this vertical line on the parent function, it is the y-axis, but the x-coordinate is 0. And you will see when we compare the axis of symmetry to the vertex, the axis of symmetry, the x is going to equal the same value as the x value in the vertex. To kind of help with the general shape of this parabola, I'm going to look at some values. So I'm going to make an xy table here quick. If we look at 0, 1, 2, and 3, and we're plugging it into my function y equals x squared, so 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, which are our points. 0, 0 is the vertex. We have 1, 1 here, 2, 4, and then 3, 9. And as you see by the symmetry, we have negative 3, 9 as well. We have negative 2, 4. We have negative 1, 1. So we have that symmetry in there. But if we think back to some of the stuff we did with sequences, we do see there is a pattern here. It's not arithmetic, it's not geometric, but if we look here, we're adding 1, we're adding 3, we're adding 5. You're adding these odd numbers. So if we went to 4, which is not on our graph, we could add 7. 9 plus 7 is 16. Or we could say 4 squared equals 16. But if we just remember this pattern, up 1, up 3, up 5, up 7, we can see in our basic parabola, we went up 1, up 3, up 5. So this next one, which is right off my graph, goes up 7. This is one way you can look and see, is this curve actually a parabola, or is there something else going on with it? So now let's look what happens when we translate this. So in blue here, I have my parent function. I'm going to use that function notation. F of x equals x squared. And remember, f of x is just another way of saying y. We have the vertex at 0, 0. We're going up 1, 3, 5. We have that same pattern going on with that. We have our nice symmetry on there. Yeah, it's our parabola. It's our parent. But now let's look and see what happens as we switch over to this red one. This is going to be our translated function. And we can say it is basically translated because you see here's the vertex and we're 1, 1, 2, 3, 1, 2, 3, 4, 5. So we have that 1, 3, 5. We're still doing that same curve, that same parabola. But to see where any point moves, the easiest point to watch move is the vertex. So we said to go from the parent over to our translated function, we went down 3 and we went left 2. So with what we remember with our translations, down 3 means our k value is negative 3. Left 2 means our h value is negative 2. So our new function is going to be f of x plus 2 for the shifting left 2 minus 3. Whoa. Try that again. Minus 3. And this is what I have graphed here. Y based on my parent function. But now let's use this f of x here to write this new equation. So f of x is x squared, so f of x plus 2 is x plus 2 quantity squared minus 3. And this is my translated function. This is the equation of this red graph. Now, some of the cool things about this is the vertex on my translated graph is the point negative 2, negative 3. And if you see that negative 2 comes in my shift 2 to the left, the negative 3 comes in my shift down. So the vertex is actually telling me my translation. That is one of the nice things about this translations with the parabola. Since the vertex of the parent function is at 0, 0, as we translate it, finding the vertex will tell me what that translation is. So, if we take this a little bit more in general, let's do it this. In general, if we look at this equation, y, and I'm going to write this as x minus h squared plus k, this is going to be a translated quadratic. And it's going to have a vertex at the point hk. So let's see if we can play with this a little bit. So let's look at this function, y equals x minus 4 squared plus 2. By the fact we have this square in here, makes me think this looks like it's a member of the quadratic family. It fits with our general quadratic, shifted quadratic, x minus h quantity squared plus k, and using that, my h is 4, so I'm moving 4 right. My k value is 2, so I'm moving 2 up. So I'm going to go 4 right, 2 up, so I'll go over 4 up 2. There's my vertex, which is going to be 4, 2. My axis of symmetry is going to go right through the vertex, and that's going to be the equation x equals 4. Now I'm going to use my relationship 1, 3, 5. So I'll go over 1, up 1, over 1, up 3. Is going to be there. Over 1, up 5 is about there. And then I can mirror it on the other side. So over 1, up 1, over 1, up another 3, over 1, up another 5, and then I can draw in my parabola. And that is the graph of my function, x minus 4 quantity squared plus 2. So now let's go the other way. Let's write the equation of this graph. Again, we look at this. This looks like our parabola. We have a vertex here. We got our axis of symmetry. We're going up 1, 3, okay, 1, 1, 2, 3, 5. So we're following that same pattern. So we know we're going to be of the form y equals x minus h squared plus k, because we're a quadratic that's been shifted, h and k. I take a look and see where's my vertex. My vertex is at the point 1, 2, 3, 1, 2, 3, 4, 5, negative 3, negative 5. And that's my hk. So I can come over here and say y equals x minus my h, which is a negative 3, plus my k, which is a negative 5. Up, and don't forget your squared. Or in other words, y equals x plus 3 quantity squared minus 5. And that's the quadratic family.